So now we are continuing again with the rings of polynomials. Yesterday we have seen how to add or multiply two polynomials. So let us have one glimpse of it. So we can see over here, this was the way we dealt with it. You took f of x as x plus 1, g of x again as x plus 1, and in z2 of x, when you added, it became 0 polynomial. If you multiply f of x into g of x, again it becomes x square plus 1. The term 2x gets cancelled. So term 2x now goes to 0. Hope you followed this. Let's have one more example of the same. F of x was 4x minus 5 and g of x was 2x square minus 4x plus 2 and the ring was z8 of x. So what you did while adding or multiplying, you divided by 8. Here you can see modulo 8 and accordingly you answered. Now let us move a bit ahead. So this was the way we multiplied or added. And what we observe is the ring, the set of all polynomials with the coefficients from the corresponding ring, they form again a ring. Now the set R of x of all polynomials in an indeterminate x with coefficients in a ring R is a ring under polynomial addition and multiplication. Now if your original ring R is commutative, then Rx is also commutative. And if R has unity 1 other than 0, then this one is also unity of R of x. So this is the theorem. What we mean by this? The ring that we are handling, accordingly we get the ring of polynomials. If it is itself commutative, then the ring of polynomials is also commutative. If R has unity 1, in that case, R of x also has unity 1. All right. Now let us move ahead. This statement I would like to highlight for you. Z of x is the ring of polynomials in the indeterminate x with integral coefficients, and Q of x, the ring of polynomials in x with rational coefficients. So this we all know now. This example we have already solved. X plus 1 bracket square in Z2 of x, just now I have shown, it comes out to be x square plus 1. And the addition becomes a 0 polynomial. Now, there is one more fact. If R is a ring and x and y are two indeterminates, then you see this is R of x means ring of polynomials in x. There is a bracket and again you are having of y, means the polynomial ring of R of x with indeterminate y. You may have R of y of x also. Then you need to show that R of x of y is the same as R of y of x, or we will say it is naturally isomorphic. So this statement is quite important for us, and this just now we are going to solve it. So this we mean to show. So let's have a question over there. Okay. So what is this question saying? Question says that consider the element f of x comma y And how it is given to you? 3x cube plus 2x bracket closure times y cube. So I would like to rewrite it for you. We are saying f of x comma y. How is this polynomial? So you can see the coefficient of y cube is actually a polynomial in x. This is 3x cube plus 2x. Y cube it is. Plus x square minus 6x. Okay, I would like to go with this. This is x square minus 6x plus 1 times y square. Plus you have bracket x raised to 4 minus 2x times y. And plus you have bracket x raised to 4 minus 3x square plus 2. Okay, so you can say this is a polynomial in indeterminate y, but the coefficients are from the ring of integral coefficients of x. So they are asking you to write. See, consider the element of q of x of y. They are asking you to write this in view of q of y of x. So how would you go for this? Yes. So if you want in terms of x, you will have x raised to 4 kind of things in the beginning. Just a minute. Here it will be x raised to 4. Then you will have term in x cube. Then you will have term in x square. Then in terms of x. And then constant. Now you collect all the coefficient of x raised to 4 in terms of y. What I observe? This is x raised to 4 times y. So my first coordinate will be y, and here again I find x raised to 4 is there. So y plus, I can say 1. Can I? What next I'll get? Plus. Let me have a bracket again. Let me just go with x cube. I find x cube here. So this is the only place where I find x cube. What is the coefficient of x cube? 3y cube. So I can call it as 3y cube. Plus. What next? That of x square. Terms in x square. Where are x square terms? I find it here and here. So what is the coefficient of x square? It will be y square. And this will be minus 3. Then we will have linear term, x raised to 1 kind of term. I find it over here. It is here also. So what I get inside? Inside I'll be getting 2y cube. What next? Minus 6y square. And what next? Minus 2y. Did you follow me? So I have noted x raised to 4, x cube, x square, x. Now I am just left with constant terms. So I have to write the constant terms. What I'll do? Plus. What are the constant terms with us? This is constant for x. There is no x here. So I'll have y square. In this bracket, there is no constant for x. Here I have constant for x as plus 2. So you can see these are all numbers. I mean the coefficients are taken from what? Q of y. And then they are written in terms of x. What we did is simply we have rearranged, nothing else. So did you follow me? Any doubt? Okay, I would like to repeat it for you. See, earlier what was given to me? It was given that it is Q polynomials. I mean the coefficients were in terms of x. So this is Q of x. Coefficients are taken from Q of x and polynomial is in the form of y. The indeterminates here were y. We will not call them as variables. The indeterminates are y and the coefficient is a polynomial in x. That is why it is Q of x of y. And what we did, we separated it. We have arranged it in as if it is a polynomial in x and the coefficients are from Q of y. Is it fine now? Is the point clear to you or not? Okay. I would like to repeat the thing for you. The polynomial is given in terms of x and y, but while giving, you see the coefficients, all the brackets, they contain polynomials in x and multiplied by either y cube or y square or y or constant. So what you observe, this is as good as a polynomial in indeterminate y. And the coefficients are polynomials in x. What we did, the same polynomial we have written, but we have collected the coefficients of x. This was x raised to 4. So we watch here x raised to 4 into y we have. This is x raised to 4 into 1 we have. So that is what we have taken. And this we could do. Why? Because in case of rational numbers, multiplication is commutative. So we could do so. Because x raised to 4 into y, here we are writing as y into x raised to 4. Why could we do so? Because in rational numbers, multiplication is commutative. So we could do so. Same way we have done over here as far as x cube is concerned. Only one term in x cube was there. So we have written it as 3y cube x cube. Then we collected the coefficients of x square here in terms of y. Then we went for coefficients of x and so on. So this is a polynomial, but now written as a member of Q of y of x. I think you followed me now.
Yes, ma'am.
Okay. Okay. Now I would like to go ahead. Eisenstein criteria yet we haven't talked of. So let us go back over here. And here it says apply division algorithm. What do you mean by application of division algorithm? Division algorithm. So we divide to the dividend by divisor. We get some quotient, some remainder. What is the condition on remainder? Remainder can be either 0. If it is non-zero, then its degree will be smaller than the degree of the divisor. That's all. So I hope you are ready now for division. So let us copy this question with us. This is x raised to 6 x raised to 6, then plus 3x raised to 5, plus 4x square, minus 3x plus 2, minus 3x plus 2, and is divided by x square plus 2x, x square plus 2x minus 3. And we are in Z7. Keep this in mind. We are in Z7. So how would you continue? This division goes as per our usual rules. So what we need to do is, first we have to think of x raised to 6 and x square. So what will be the quotient? This will be,
X
come on, x raised to 4.
raised to
Okay, x raised to 4 into x square. It will give us 4 plus 2. X raised to
6.
6. Yes. Then you'll have, come on, plus twice x raised to 5 minus thrice x raised
X
to
raised
4. Okay. What next I'll get here? This
minus L.
minus, yes, we are subtracting. So x raised to 6 goes off. This is 3x raised to 5 minus 2x raised to 5. We will be
X
getting
raised to 5.
single.
X
Yes,
raised to
x raised to 5. This will be what? Plus 7x raised to, no, sorry. There is no x
plus
raised to
4x
4.
raised square minus 3x raised to 4.
It is 3x raised to 4 only. And there is no cube term. So I have to just carry the rest of the things. 4x square
Minus
minus
3x
3x plus 2. Yes. Now let us once again carry our division. So what I'll have
x raised
next?
to 3.
Yes,
X
plus
raised to
x cube. Yes, x raised to 3. Now what it gives me? X raised to 5. Come on.
plus 2x raised to 3.
4. And minus 3x cube.
3x.
Again we are subtracting. So what the result of subtraction is? Subtracted. So signs are changed over here. And this gets cancelled. 3 minus 2 gives me 1. 1x
X
raised to
raised to
4. Then I have plus 3x cube.
4. 3x cube plus 4x square
Yes, plus 4x square
minus 3x plus 2.
minus 3x plus 2. Okay. Now what will be the next quotient?
X raised to 2.
Yes, it will be plus x
X
raised to
raised
2. Yes. What it produces?
X raised to 4
Yes, x raised to 4
plus 2x raised to cube
plus 2x cube. Yes.
minus 3x square
Minus 3x square. And now we have to subtract. Okay. For subtraction, we have to change the signs.
sign
Okay. So this will be minus, this will be minus, and here I have plus.
plus
Now what is the output?
x cube plus 3x square
Yes,
plus
so
4x
this will be single x cube. Yes, you're right. Then
sorry, plus x square.
it
No,
will
no.
be 4 plus
7x
3.
square. 7x
7x
square.
square, but you are in Z7.
0, no?
Then it will be 0x square. So I won't record this x square. What next?
Minus 3x plus 2.
Yes, minus 3x plus 2 you are getting. Now let us once again go to our divisor. X square plus 2x minus 3, and
X
we have,
plus x
so
plus x
yes, we need to have
plus x.
plus x. So let us go to plus x. What this plus x is going to produce? Plus
X
x
cube.
cube.
Hmm.
Huh? Plus 2x
Minus
square.
3x.
2x square
Sorry, what is
plus
that?
that one, and this is
Hmm.
minus 3x. Let us once again check whether we have written correctly or not. We multiply by x. So it is x cube,
2x.
2x
X cube.
square and minus 3x. Okay. Now we
Hmm.
are subtracting here. We have to change the signs.
Hmm.
Let us change the signs. This is minus and here it is plus. So
Plus.
what do we get? Minus 2x minus 3x square. No, minus 2x
Hmm.
square is there. Then this gets cancelled and we have simply
Cancel.
plus 2 over here.
Hmm.
Sure?
Hmm.
Now this is not the remainder. We need to talk in terms of Z7.
Hmm.
So in Z7, what is minus 2 equivalent to? We want
Module
modulus 7.
5 into
Yes, it
3.
will be 5. So what do we get? This remainder is nothing but 5x square plus 2. And what is the quotient? Let us see. Quotient is x raised to 4 plus x cube plus x square plus x.
Hmm.
Are you following the thing?
Yes.
Sure. Okay. So do you want to repeat the thing? All right. So it's a good thing nobody wants it back. So what you need to do is just copy down these questions with you. You have now understood what is to be done. So I want answer from you for B, C and D. You'll take the polynomial f of x given, divide by g of x, and once you reach to the final point, either in terms of in quotient or in remainder, you see whether all the coefficients belong to Z7 or not. Okay? And just
Yes.
find out the remainders when divided by 7. Now for C and D, you are given Z11. Okay? So I hope it is quite possible. You can do it.
Hmm.
Sure? Ready for the next? Okay. Now going back over here. I want to focus on this particular. See here, if D is an integral domain, then D of X is also an integral domain. Up till now, we were simply talking about the ring, but now we are talking about integral domain. So if D is an integral domain, then D of X, ring of polynomial with coefficients in D, is itself an integral domain. What is an integral domain? Yes. What is an integral domain? Okay, these are the basic things you must know. Okay, it's a ring with unity. Is it necessary to have unity? Yes. Then there are no zero divisors in it. That is the basic requirement, without zero divisors. Okay. Now, if f is a field, then f of x becomes an integral domain. Okay. F of x, will it be field? If f is field, do you think f of x will be a field? For that, you can see this red mark. F of x is not a field because x is not a unit in f of x. X is not a unit, means x has no inverse in f of x, because field requires inverse for every element. Every non-zero element must be invertible. Now this x raised to 1 is not invertible here. Why? Because there is no polynomial f of x such that x into f of x will be 1. Is it okay? And that is why f of x cannot be a field, but surely f of x is an integral domain. Keep this in mind. Okay, for 1 mark kind of questions, this might prove helpful. Maybe they'll ask you, if f is a field, f of x is not a field or is a field, justify. Then you can say f of x is not a field because every polynomial is not invertible, but the proper word is not a unit. So very basically you can show x is not a unit in f of x. Why? Because we cannot find any polynomial such that x into f of x is 1. Can you give me any polynomial such that x into that polynomial will be 1? Product of two polynomials equal to 1. So you know better, if I multiply by x to any polynomial, what is going to happen? Degree of this product is sum of the degrees, you know. So degree is equal to what? Suppose this is square degree. Okay, you have x square. So what happens? Degree of the product is 1 plus 2. Means degree is increased by 1. It is not decreased. And we want this to be a constant. 1 is a constant. Its degree is 0. So this is impossible. And that is why we are saying that x is not unit element. X is not invertible element. Followed me? Okay. So I think for today this is enough. I would like to stop here itself. Anybody wants to ask anything?